Hello class, and today we are going to look at distance formula. What we're going to do with this, we're going to use this to find the distance between 2 points on a coordinate plane. All right, so the first one, we want to find the distance between point A at 3, 5 and point B at -5, -1, and we're actually going to cheat a little bit on this one because we have it on a coordinate grid. So we can do something that makes it a little bit easier for us. And what we're going to do is we're going to take the grid line and we're going to use that to draw a right triangle. And there it is. And the reason we're going to do that is because, one, if it's on the grid line, then I can just count, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 6. It's hideous. Let's try that again. 6, right? Can I count the distance from A to B, though? No, because this one, it's at an angle. And what about this little bitty piece right there? How would you count that, right? So you can't just count it. But if you have a right triangle and you're just missing one side, we can use something that we've used before. We don't have to learn anything new for this. We can just use Pythagorean Theorem, which, remember, is c squared equals a squared plus b squared, right? Where A and B are two legs, and C is the hypotenuse, that one that's at an angle across from the right angle there. So it's all diagonal there. And I'm not going to call it C because I'm looking for distance. I'm going to call this D for distance. Okay? So let's take this and put it over here. We have D squared equals 8 squared plus 6 squared. And I'm not really interested in D squared, I'm just interested in D, right? So I'm going to get rid of the square by square rooting both sides, and D is equal to the square root of 8 squared plus 6 squared. And now I can just work this out. So let's see, D is equal to the square root of 8 squared is 64 plus 6 squared, which is 36. Add those up, and D is equal to the square root of 100. Take the square root, and D is equal to technically positive 10 or negative 10. Because if you remember, everything has two square roots, a positive and a negative. But since I'm just looking at distance, and distance can never be negative, I just want the positive 10. Positive 10. So the distance is positive 10. Now, what we're going to do here is we are going to take this, and we are going to turn this into a formula, so that I can do this when I don't have a coordinate grid, right? Because notice the next one, there's no coordinate grid, right? It just gives us some points. So how do we do this? Well, we're going to take this row right here. So we're going to take this one and we're going to turn this into a formula. So we're just going to bring it down here. So we have a distance equals the square root, right, of 8. Where did the 8 come from? Well, the 8, that came from this right here, right? So that is just the distance between the x values. Okay, so it's distance between our x here, x1, and x2, right? That's all that is. So that's how we'll write this down. Let's just take x1 minus x2 squared. All right, and then we had plus 6 squared, so plus, and the 6, well, the 6 did the same thing right here on the y-axis. So that's just the difference between the y's. So let's see, our y value here, we had y1 and y2, and we just subtracted those. y1 minus y2 squared. And this is where the 8 and the 6 comes from, right? And so this is our formula. So now when we go to that next one, we've got the formula. We can just plug the numbers straight into the formula, and it doesn't matter that we don't have a grid. So let's go ahead and do that. Here it is. We need to find the distance between point C at 3, -4 and point D at 10, -5. We have no grid, nothing to do we can use for this except we're looking for distance. So let's write down the distance formula. All right, so square root of D equals the square root of x1 minus x2 squared plus, in parentheses, y1 minus y2 squared. All right, now all we have to do is plug this in. D equals the square root of, we gotta decide which point is 0.1 and which point is 0.2. Honestly, it doesn't matter, not even a little bit. So we can just say that C is 0.1 and D is 0.2, because why not? So this would be x1 and y1, and this would be x2 and y2. Okay, so let's plug in here. We have x1 is 3 minus x2, which is 10 squared, plus y1, which is negative 4, minus y2, which is negative 5 squared. And extend that out. And let's start working this out. Okay, D equals the square root of, let's see, 3 minus 10 is negative 7 squared, plus negative 4 minus negative, remember minus and negative, that's like adding. So negative 4 plus 5 would be 1 squared. D is equal to the square root of, and if you're not careful right here, you put this in your calculator, and your calculator is going to give you the wrong answer. Your calculator is going to tell you that negative 7 squared is negative 49. But remember, this is negative 7 times negative 7. Negative times negative is a positive, right? Everything squared is positive. The reason for that is your calculator is going to take this, if you type it in like that, and it's going to treat it like this. So it's going to square the 7 and then apply the negative. That's not what you want. You want it to do it like this. Apply the negative to the 7 and then square that to get you your positive. And so, let's see here, I need to get rid of that. Okay, so negative 7 squared is positive 49 plus 1 squared, which is positive 1. Gives me an answer. Distance is equal to the square root of 50, which is some hideous decimal that we're not going to deal with. Instead, what we're going to do is we are going to simplify the square root of 50. Hopefully you remember how to do that, but if not, that's okay. We'll do it right here. We're going to take the square root of 50, and we are looking for factors of 50. Okay, specifically, we are hoping for factors that are perfect squares. And if you can think of some, that's great. But if not, you can just do a factor tree. And let's just look at prime factorization. Let's see, 50 is 5 times 10. So square root of 50 would be the square root of 5 times the square root of 10. Okay. Are either of those perfect squares? No, they're not. Are either of them prime? Well, 5 is prime. So that means we're done with the 5. We're going to keep going with the 10. So 10, we have square root of 5 and square root of 2. Okay, those are both prime, which means we are done with those. So what we said was perfect squares, which we didn't come up with perfect squares. And so now we're looking for pairs, because a square is something times itself, which you notice I have a pair right there, which comes together, and that could be the square root of 25, which is just 5, out from under the square root symbol, which is what I want. All right, so the square root of 25 is 5, and I'm left over with the square root of 2, which has nothing to pair up with, so it's just square root of 2. So that means my answer is 5 square roots of 2. And there is the distance from point C to point D. All right, last one down here. The endpoints of segment EF are E at 4.3, F at x negative 6. Find the possible value or values of x that makes the length of EF equal to 15. Okay, so this is a little weird because we have this variable right there, but that's okay. We're still just going to take this and plug it into the formulas. All we're going to do. So, well, first, if I'm going to plug this into the formula, I have to decide which one's 0.1 and which one's 0.2, which you can just do this easily and say the first one is always 0.1, the second one is always 0.2. Easy enough to do, and that's fine. But it really, you can switch them around. We don't care what order they're in. So I'm just going to call this x1 and y1, x2 and y2. Helps me to plug them in. Okay, so D. I actually know what D is this time. D is 15. So I'm just going to plug that into D. Equals the square root of, let's see, parentheses, x1, which is 4, minus x2, which is x squared, plus, parentheses, y1, which is 3, minus y2, which is negative 6 squared. All right, so now let's start working this out. I want to get x by itself, right? Well, x is underneath that square root symbol, so I want to get rid of the square root symbol, which, if you remember, we do that by squaring it. So I'm going to square that side, I'm going to square that side, and so now I am, where my pen go? There we go. See, 15 squared is 225 equals, my square root symbol is gone, so now I have 4 minus x squared plus, and I'm going to go ahead and combine this. Let's see, 3 minus a negative 6, that's the same as saying 3 plus positive 6 is 9, squared is 81. So all I did there is I just took all of this and I simplified it to that. That's all I did. Okay, so now I want to get rid of the 81. So let's minus 81 to both sides. All right, and so that gives me 144 equals 4 minus x squared. Okay, now I want to get rid of that square, and so I'm going to square root both sides. And here we run into a small problem where people mess up a lot. Remember, when you square root a number, you get two answers every single time. You get a positive answer and a negative answer. So the square root of 144, that could be 12, which would then equal 4 minus x, or it might be negative 12 equals to 4 minus x, all right? Because remember, a square root, you get two answers. You get a positive and a negative. Now, either way, we are now going to subtract the 4 from both sides. So minus 4, and we're going to do the same thing over here, minus 4. And that gives me, let's see, 12 minus 4 is 8 equals to negative x. And negative 12 minus 4 is negative 16 equals to negative x. I want to get rid of the negative there, so I'm going to divide both sides by negative 1 all the way across here. Divide by negative 1. And that gives me that x equals negative 8 and x equals positive 16. So my solution, x equals negative 8 or positive 16. Right there. All right, so that one is a little tricky. Still just plug it into the formula, and remember, right here, you end up with a positive or a negative. You get both every single time. So don't forget that when you have a square root, you always get two solutions, a positive and a negative. All right. Don't forget to simplify your radicals. You're looking for pairs and squares, right on that. And over here, just distance formula is nothing more than Pythagorean Theorem. So if you have it on a grid, you can just do Pythagorean Theorem. If not, use the distance formula and just plug it in. Hopefully you found that useful, and I will see you in the next video.